You know, when we talk about securing a blockchain, I mean, the really heavy duty stuff, you picture these vast windowless warehouses.
Right. Full of humming machines.
Exactly. Humming ASIC miners burning just an incredible amount of electricity. And frankly, it's very industrial. It's loud. And it's so boring.
It is. It's just raw computation. It's brute force,
Yeah.
really. You're turning energy directly into security, and the main byproduct is just heat.
But today is different. We're looking at a stack of documents that proposes something that honestly sounds like a gamer's fever dream.
Uh-huh.
Imagine securing a global financial network, not by, burning coal, but by clicking heads in a video game. Imagine your skill at landing a headshot is the actual cryptographic proof that validates a transaction.
It sounds completely ridiculous when you say it out loud like that.
It does. It sounds like a joke. But we've been digging through the sources, specifically a yellow paper draft for a protocol they're calling SkateChain, some C code for a shooter called Shankpit, and dev notes for an MMO with the incredible working title of Dragons and Shit.
Heh. That's the hook, right? You come for the funny names, and I mean, Dragons End shit is an all-timer.
It really is.
But you stay because they are genuinely trying to solve the bot problem in a way nobody else really has. This is all about what they call attention mining.
Right. So that's the mission for this deep dive. Can fragging someone or, exploring a digital forest, can that actually be a security primitive? Can the adrenaline and the mouse jitters of playing a game replace the raw energy cost of something like Bitcoin?
It's a very bold question. And to answer it, I think we have to look at why the last attempt at this, the whole play to earn cycle, failed so miserably.
Let's start there. Because we've all seen crypto gaming before. Axie Infinity, all those games where you buy an NFT and just grind for coins.
Right.
They promised a revolution, but mostly they just created, digital sweatshops.
Precisely. They became script to earn. The entire economic model just collapsed because it didn't require humanity. It just required inputs. So you'd get these bot farms, thousands of accounts running in a basement somewhere, just extracting all the value and crashing the economy.
And ruining the game for anyone actually trying to have fun.
It was purely extractive. That's the mercenary capital problem the white paper talks about. People were there for the money, not the game.
So SkateChain's new thesis is attention as security. The core idea is that the cryptographic work, the mining, is only valid if the network can mathematically prove a human is paying attention to the screen.
And that solves some huge problems. The first one is the Sybil attack.
Let's unpack that really quick because it's a term you hear all the time in crypto.
Sure. A Sybil attack is just identity theft at a massive scale. If I want to control a network, I can spin up, say, 1,000 fake computers or nodes and pretend there are 1,000 different people.
And if you control the majority, you control the rules.
In a traditional system, yeah, you just buy enough cloud servers. But in this proof of fund model,
You'd need 1,000 actual human beings sitting there playing the game.
and not just playing, but playing well. One of the wildest things in these notes is a concept they call proof of frag.
I saw that in the Shankpit code comments. It sounds like something from a leaderboard, not a blockchain protocol.
But they're dead serious. The protocol actually gamifies mining difficulty. If the game server officially signs off that you got to kill a frag, your mining difficulty drops by 20% for a little while.
So wait, let me get this straight. Being good at a video game makes your computer more efficient at mining crypto.
Yes, in this ecosystem, skill issues will literally cost you money. If you keep dying, your computer has to work harder to find the same block.
That's wild, but it also solves that cold start problem, right? Usually these networks are ghost towns until speculators show up.
Exactly. Normally, you have to bribe people to run nodes. Here, people show up because they want to play the shooter. They're there for the game. Securing the network is just a happy byproduct of their leisure time.
Okay, I have to pump the brakes because my inner skeptic, and I think you're with me on this, is screaming, I can fake this. I'm a programmer. I can just write a little script that tells the blockchain, hey, trust me, I'm fragging out over here while I'm actually, making a sandwich.
And that is the billion-dollar question.
Mhm.
How do you verify the fun? The answer is in the architecture, specifically what they call the IPC protocol specification.
IPC, inter-process communication.
Right. So your computer is basically running with a split personality.
Mhm.
You've got two programs. First is the game client, the GC. That's the fun part, renders graphics, handles your mouse, shows you the explosions.
Okay, and the second part?
That's the node client, or NC. Think of it as the boring accountant. It's the part that talks to the blockchain, gossips with other nodes, builds the blocks.
So the accountant needs to know the gamer is actually, gaming,
Precisely. And they do not trust each other. That's the key assumption. The code we have shows this very specific handshake procedure. It starts with a magic header,
Oh, I love these. It's 0 by 534 B4154.
which in hex spells out SkateChain. You know developers love their little Easter eggs.
Of course.
So the game client sends a hello message with a session nonce, just a random one-time number. The node client sends back a challenge, and they verify each other to make sure nothing's been hacked.
Okay, so they establish a secure line, they shake hands, but what stops me from doing that handshake and then just walking away?
A heartbeat. Every single second, the game sends a message. It contains the average frame time and something called an entropy score, which is the really clever part.
And I see a penalty in the code here, a slashing condition.
Oh, it's brutal. The spec says if your FPS, your frames per second, drops below 24, your mining intensity is immediately forced to 0.
Wait, so if I tab out, if I minimize the game to check an email,
Your game stops rendering frames to save power. Your FPS hits 0. The heartbeat stops. And the accountant, the node client, says, nope, the gamer's on a break, and cuts off all mining instantly.
so you can't background mine. You literally have to burn GPU cycles on the game itself to earn the right to burn cycles on the crypto.
It's proof of rendering.
Mm-hmm.
You're proving the hardware is being used for entertainment.
Okay, but I'm going to double down on my hacker persona. I don't need a monitor. I can run a headless bot. I can create a virtual graphics card that just tells the system it's rendering 60 frames per second.
And this is where we get to that entropy part.
Yeah.
This is the coolest bit. The system isn't just asking, is the game running? It's asking, is a human running it?
And they're defining human as chaotic.
Pretty much, yeah. The code calculates what they call an entropy hash. It look at your mouse deltas, how far you moved your mouse between frames, your key press timings, all the micro variations.
Because humans are jittery. We're not perfect.
We're a mess. We overshoot things, we hesitate, our reaction times are all over the place. A bot script. It moves in perfect straight lines. It clicks at perfect 100 millisecond intervals. The protocol runs a spectral analysis on your inputs, and if your movements look too smooth, too mathematical.
It flags you as a robot.
Exactly. Low entropy equals no mining. It's analyzing the noise from your nervous system.
That's incredible. But devil's advocate again, what if I just hack the accountant? I rewrite the node client to ignore the entropy score and just mine anyway.
They thought of that. There's a feature in the notes called shared memory attestation.
Okay, break that down for me.
Think of it like a locked glass box. The game client, the fun part, puts a piece of paper in the box with the real entropy score. The node client, the accountant, can read the paper through the glass, but it can't open the box to change it.
It's using the operating system's own memory protections to create a one-way street of information.
Exactly. To beat this, you'd have to compromise the Windows or Linux kernel itself, which is a much, much higher security bar than just writing a simple bot.
And on top of all that, to fake a frag, you need to compromise the main game server, not just your own machine.
It's defense in depth. Layer after layer of prove you're actually having fun.
So the security model is solid, but let's look at the games themselves. Because we start with Shankpit, a Twitch shooter, but then the notes move to this MMO, Dragon's End shit. I still can't get over that name. I really hope they keep it. But the tech for an MMO is totally different.
Completely different. A shooter is all about tick rate. How fast can we update player positions? An MMO is about persistence. Where's my stuff? What level am I? Who did I trade with?
And the dev notes mention a very specific database choice, BadgerDB.
Yeah, this is a cool detail for anyone into back-end tech. Usually a game would use something huge like SQL, but BadgerDB is a key value store written in Go.
And why does that matter here?
Because it's embedded directly in the application. It doesn't have to talk to a whole separate database server. It saves a ton of overhead. It means the game can handle thousands of little player state updates with super low latency, which is critical if you're trying to verify gameplay for a blockchain in real time.
The aesthetic of DNS also sounds unique. Rotoscoped voxel.
I love this. When you hear voxel, you think Minecraft, right? Big, chunky blocks.
Yeah, 1 meter cubes.
DNS is using a 1/4 meter grid, so 4 times the detail. And the rotoscoping is a shader. It draws a heavy black line around the outline of things and a white line just inside. It gives it this kind of high contrast comic book feel.
Huh. Almost like Borderlands meets a high-res Minecraft.
That's a great way to put it. And that stylized look also, conveniently,
Yeah.
gives the GPU something specific and computationally heavy to do, which makes that proof of rendering even harder to fake.
The notes also lay out the zone logic.
Yeah.
You have the safe town and then the forest with, and I'm quoting, aggressive dragonkin.
And Moving between them is a technical challenge. They're writing custom TCP listeners to hand off your session from the town server to the forest server, and they're trying to make it seamless.
No loading screens.
Right, because if there's a pause, if that handshake breaks, you stop mining. The seamlessness is actually a financial requirement of the protocol.
This all just reinforces that they're building a real game engine here, not just some crypto project with a game slapped on top.
And that's the absolute key. For proof of fun to work, the game has to be fun. If nobody wants to explore the forest, nobody is securing the network.
Which brings us to the bigger picture, SkateChain.
That's the protocol layer. The vision is permissionless integration. They want any developer with any game, a fishing game, a racing game, to be able to plug into the system.
So an indie dev could use SkateChain for their security and economy.
That's the idea. And you avoid the centralized overlord problem. The notes talk about a federated master server run by a DAO, a community, so one company can't just flip a switch and turn off the economy.
Okay, but someone has to finalize the blocks. The players are mining, they're doing the work. Who validates it?
The validators. And this is the twist I think is just brilliant. The white paper suggests a hybrid model. To even be a validator, to govern the network, you might be required to actually play the game.
You're kidding. Mandatory gaming hours for the board of directors.
Basically, something like 10 hours a week of verified gameplay to keep your validator seat. It forces the people making decisions to be actual users of the product.
That aligns incentives in a way you almost never see.
It creates this player validator class. It keeps governance grounded. You can't vote to make the game a miserable grind to earn more fees if you have to suffer through that grind yourself.
The future work section also mentions mobile.
Which is a huge market.
Yeah.
But it's hard, right?
Yep.
No mouse, no keyboard. How do you measure entropy?
Proof of tap patterns?
And gyro entropy, using the phone's accelerometer. Humans hold their phone with a tiny shake. We tilt it when we get into the game. A phone in a bot farm rack is perfectly still. It's a clever adaptation of the same principle.
So to sum it all up, we're moving from play to earn, which was basically just speculation, to play to prove.
Right.
Using the beautiful chaos of human reaction time, verified by all this clever tech to secure a financial ledger.
It's turning what we think of as wasted time into digital concrete, finding real utility in leisure.
There's a catch. You mentioned something to me about a security degradation curve in the notes, and I think we have to end on this because it feels like a dark cloud over this whole beautiful idea.
Yeah. This is the big provocative thought.
Uh-huh.
In Bitcoin, security is paid for with electricity. As long as you pay the bill, the network is safe. It doesn't care if the miners are happy. But in SkateChain, security is paid for by fun.
So, what happens when the game gets boring?
That is the existential danger. The notes show this curve. If your active player count drops from, say, 10,000 to 1,000, the network's security, its hash rate, collapses by 90%.
That puts a terrifying amount of pressure on the game designers.
It really does. Imagine a developer pushes a bad patch. They nerf a popular weapon, players quit in rage. Suddenly, it's not just a bad game update. The currency itself is now vulnerable to a 51% attack because the army that was guarding it just rage quit and went home.
The game developer becomes the central banker. They're responsible for the health of the currency, not through interest rates, but through game balance patches.
Nerf the shotgun, crash the market. It is a wild, wild future to think about.
It really is. Can a game be fun enough, long enough to hold up a bank vault? I guess we'll find out.